Okay, so for my discussion 9, I was given the sample size of 1,120 people for babies born in Iowa in 1996, and this is data sheet number 7. So the first thing that I did was all of my data is over here on this page, but we'll get there in a second. So I took all the data and I put it in this frequency table to summarize it all up. So these were the numbers of exact births that happened on each day of the week and their relative frequencies or percentages. So the first thing I did was I made a histogram displaying that information. So as we can see on this histogram right here, there isn't really a lot of big spikes or big dips in our data. All of our percentages are between 11 and 16%, with our highest being our 16% on Wednesday and Friday, and our lowest being 11% on Saturday. So there is variation, but it doesn't trend in too much of an upward or downward direction. So I wanted to do a hypothesis test to see how this all played out. So the first things that we have to do before we do a hypothesis test are our assumptions. So random sample, it's clearly a random sample, and the 10% condition are the assumptions that I found the most valid. The 10% condition meaning this is less than 10% or less of all babies born in Iowa, which 1,120 is definitely less than 10% of the babies born in Iowa in a year. So from there, I created my null hypothesis, which is birth on any day of the week is evenly likely, and then my alternative hypothesis, which is birth on any day of the week is not evenly likely. So from there and from those assumptions, we are able to carry out our hypothesis test, which brings us over here. So we take all of our frequencies and our expected frequencies. So the expected frequency would be 160 births per day of the week, and then so that would be about 14% if we're thinking of that in terms of percentages. So from there we subtract our obtained from our expected, get the difference, square it, divide it by the value, and then from there I add up all of those sums to get our test statistic. Our test statistic was about 2.48 is what I would round it to, and then from there I was able to calculate a p-value due to this lovely function right there. But we'll get there in a second. So what does this test statistic mean exactly? So what it means is I went to our graph and I graphed it about 2.5. Here is where our star is. And from there I was able to determine that our test statistic, we would shade everything to the right of it in the right end. And just immediately knowing that that is much greater than our 5% significance threshold, I automatically already kind of knew that we were going to retain our null hypothesis. And then just to double check that and make sure everything, I go to our chi table and I get to 6 degrees of freedom, and then 7.84 would be 25%, so then we come here and we would look up where 7.84 would be, and that would be 25%. So we have much greater than 25% even over here at 2.48. To get the exact value of what is shaded, I calculated the p-value, which would give us about 87%. We would expect results at the odds about 87% of the time. So we are clearly in the right to accept our null hypothesis. So what this means, in conclusion, is that we can retain our null hypothesis because it is consistent with our data, the data that we have obtained through all of this, and because there's no evidence in this study or with this specific case to disprove it. Not fully saying it is correct in all cases, but in this situation we have no evidence to disprove that this null hypothesis of birth on any day of the week is evenly likely as not true. Since we accepted our null hypothesis, there's no need to get the standardized residual, and that's about it. So thanks for listening.